Shalom IT lovers of my classes, welcome to Easy Machine Learning number 4.2 with Python on Google Colab. Of course, you are invited to watch my previous PY and ML tutorials. Last week we analyzed a simple market basket and saw that Apriori Algorithm successfully found the frequent item sets and generated association rules. Today, let's dive into a more advanced project using the Apriori algorithm to identify and analyze frequent item sets and association rules in a large retail dataset. We'll use our online retail dataset from the UCI Machine Learning Repository. Thank God again, I'm about to tell you the same thing in German and French. Heute tauchen wir in ein fortgeschrittenes Projekt ein, bei dem der A-priori-Algorithmus verwendet wird, um häufige Artikelsätze und Zuordnungsregeln in einem großen Einzelhandelsdatensatz zu identifizieren und zu analysieren. Wir werden den Online-Retail-Datensatz aus dem UCI Machine Learning Repository verwenden. Gott sei Dank erzähle ich wieder dasselbe auf Französisch. Aujourd'hui, plongeons dans un projet plus avancé utilisant l'algorithme a priori encore pour identifier et analyser les ensembles d'articles fréquents et les règles d'association dans une grande base de données de vente au détail. Nous utiliserons une base de données qui s'appelle UK Based Online Retailer qui se trouve dans le ML UCI Repository. Dieu merci, je vous ai dit la même chose encore une fois en anglais et en allemand et maintenant en Python. All right, let's start with some comments first. Project called Overview Advanced Market Basket Analysis with a priori again. A priori second round algorithm. Let's write a couple of comments here. Okay, the objective will be to, let me write it like this. Identify and analyze I can correct that afterward. These are just the comments. And analyze frequent item sets and association rules. And here, for the data set, we'll use the online retail data set from the, as I said, from the UCI Machine Learning Repository, and this data set contains transactional data for UK-based Okay, now let's go here and just for those who don't know what I'm talking about when I say retailer, a retail means, let me put it like this, a store, a simple store, sale of goods to put it goods to the public. Okay, at first we're gonna data preparation. Let's add that one here so we can start. Okay, now let's start first to import again our pandas as PD. Then here we want to load the dataset, which is a link. It's an Excel link. So I'm going to stick it right here. So I'm going to type here URL equal, of course equal and not plus. And I stick the URL right here, which is an Excel sheet. And we move on with data equal pd dot read. It's an Excel, so we have to indicate it here. URL. Okay, we're good. Display the first few rows of the data set. And here we get print exploratory data analysis, ADA. And we want also to check for missing values. This is what we want to do. So here we just print data dot is null, and when it's null we want a sum, so dot sum. And our next comment is going to be drop rows with missing values. And the way we do it with data drop now, we have fill now, but this time we want to drop now subset equal customer ID. And then we want here to convert invoice to and this is how we do it. Data invoice date equal PD to we're gonna get it like this, to date time. And here we want to display something else. Display the unique number of items. So we're going to print data description. Okay, now I'm going to speed the process a little bit. Okay, after the displaying the basic statistic, so we also display the unique number of items, pre-processing for a priori algorithm, filter for only positive quantity, create a basket for each invoice, and here we had to do the fill now, first the drop now, here the fill now. And now let's move on with, we have to now convert the quantities to 1 or 0. which is presence or absence of the item. Okay, as comment here, and now here we're going to use, I hope you remember our lambda function in Python while we were doing our classes, Python classes. Here we're going to need it. Basket dot apply map, and here we want a lambda x one if x you're gonna get it here bigger than 0, else 0. Okay, this is our lambda function right here, and after that we want to print. Let's just print here, and this is where we need our from mlextend dot frequent patterns. We want to import a priori. Here we are going to use column names. Call names equal to true. I think I have to stick it like this, or else it's going to be a typo. We don't want no typo. Use call names true, and after that let's just print here. Okay, after mining the association rules, we want to generate the association rules and display the rules. Evaluation and interpretation, sort the rules by lift. So we have our code right here. Now we are almost done. We want to display the, like before, you know, the first a priori with the little basket market. Now it's a retailer, but we want the same things, and for the interpretation is going to be the same. So I will not have to repeat, but I just want to show you that we can do we can use a priori for a little basket market or also for a retail. Okay, let's display here the antecedents, the consequence, the support. We want to see the support and the confidence. We want to see also the lift and lift. Let's get it like this. Let's start. So for index rule in rules for looper dot head, and here we want to move on with print. I'm going to print a couple of things here. So we need a feed form here, F, and then a rule. I'm going to get rule now in lowercase, and then antecedents. Okay, so we display the top 10, and then for each rule display, as I said, the support, the confidence, and the lift. Now we are done with the whole code, so all we gotta do is to run. It's gonna be a huge output, so it's gonna take long to you know, to analyze the whole thing, and then I'm gonna show you the output. And okay, now as you can see, our output is good now. So let's go down, we scroll. This is a huge output, but let me go to the top first so you can see where it's starting. Okay, so here is the description, the quantity, you know, the invoice number, unit prices, etc. As you can see, they're talking about 5 rows multiplied with 3,877 columns. So it's a huge thing. What I just wanted to show here is that this one is an advanced one, an advanced project which demonstrate how to use Apriori algorithm on a real world retail dataset to discover frequent item sets and association rules. These insights can be used for improving business strategies such as product placement, cross-selling, and inventory management, And of course, you can expand this project further by experimenting with different support and confidence thresholds, visualizing the association rules, and integrating the insights into a decision-making framework. Okay, this is the part which is interesting for us here, the antecedent, the support, the consequent, the confidence, and the lift. This is pretty much the same type of analysis we did with the little market basket. We also have the leverage, the conviction, and the swank metric. It's just a huge output. Okay, conclusion. This advanced market basket analysis reveals strong association between items in the retail dataset. The high lift values indicate significant relationship between the products, which can be leveraged for marketing strategies such as product placement, promotions, and cross-selling. Of course, you can further expand the analysis by visualizing these rules, adjusting the parameters for a priori to discover more or fewer rules, and integrating these insights into a broader business strategy, of course. Anyways, I hope you liked it. God willing, the rest is coming next. It's going to be our last project for machine learning, and then we're going to start something else. All right, thank you for watching. Bye.